So it's good to understand the past while we delve into the future. And that's how I structured my presentation today. And what we can do is, I guess we have 1.5 hours today. So I will try to complete my presentation in about 1 hour, and we can have half an hour for discussions. Does that sound right?
Yes, sir.
Perfect. Thank you. I guess you can see the first slide of my presentation. So what I want to talk today is about where networks would be in the AI era. Now, we are well and truly already into the AI era, right? But this is still baby steps. And if we think that we are probably about 2 or 2.5 years into the AI era, we need to look at it from a perspective of how long will this AI era continue. My feel is that whatever is happening now is just the start of what would be an AI era and would continue for another maybe 15 years or so. Now, when I say continue for 15 years, it doesn't mean it will end at the end of 15 years. It just means that something else will come up, or this itself will evolve into something absolutely new. So we're probably just about 5% or less than 5% into the AI era. So that's the reason why I thought it'll be important to understand where networks would be going forward. And the topic of the presentation today is the networks for AI edge inference. I'll get into why I'm referring to AI edge inference here, and that will help us sort of peek into the future. So if you sort of broadly look at how things have evolved from a computing perspective over a period of time, most of you might be aware, some of you who are relatively young might not necessarily be aware of it, but there was this whole thing started off with the mainframe era, where you had massive mainframe computers. A few people could sit very close to these mainframe computers using dumb terminals, access the mainframe, and use the massive computing infrastructure that was there. And that was practically all about centralized computing, right? The mainframe was the central computer, and the network was there, but it was practically irrelevant in the larger scheme of things because it was all being accessed in close proximity of the compute infrastructure. And then that evolved into a client server architecture with the growth of networks, with Windows becoming a personal computer operating system, with personal computers having a good amount of CPU, and whatever CPU was there in personal computers, be it the PCs that were the x86 PCs at that point of time running a Windows 3.1 or whatever, was sufficient enough for doing a lot of things for a large distributed infrastructure. So there was certain amount of computing that used to happen on the Windows machines or the personal computers. And then there were the backend servers, which were the massive servers that were there, not necessarily mainframe in all instances, because that's when the Linux or the Unix servers came about. And then there was a significantly large compute infrastructure at the backend, but a significantly important computing that was happening on the end devices at that point of time, personal computers, right? And as and when things started growing from a network perspective, as and when the networks became a lot more powerful, as and when we realized that we can be connected to the compute infrastructure from anywhere in the world, you had the cloud infrastructure build up, right? And cloud once again was going back to a centralized compute infrastructure. But because of the fact that the networks were extremely powerful, you could connect to the cloud from anywhere in the world, and then the cloud infrastructure happened. Around the same time, just after the cloud infrastructure built out, the mobile infrastructure already obviously took off, and mobiles were becoming more and more powerful. The compute infrastructure, the compute power that was there on the mobiles was obviously pretty good. It started building up, and that's when mobile apps became extremely prevalent all over. That's when the app stores and everything happened, right? And that point of time, once again, you had a significant amount of computing happening on the mobile device. A lot of your apps would do a lot of work on the mobile device itself and then talk to the backend for whatever has to be done from a centralized perspective. So you've seen the centralized computer in mainframe, distributed architecture in client server, going back to the centralized cloud, and then distributed computing once again from a mobile app perspective. And this cycle of centralized compute infrastructure followed by distributed compute infrastructure has been going on right from the mainframe days. Now, currently, what's happening? What's happening is basically there's these large, massive, power-hungry data centers that are there, which are AI data centers. And then these AI data centers are catering to the world all over. So whether you're using ChatGPT or whether you're using Claude or whether you're using Gemini, massive data centers, which are centralized data centers, are all catering to everything that is happening all over the world, whoever is consuming AI, right? So if you look at it, there was this era one, which was all built for servers. This was all for mostly the client server traffic. The network connected users to a handful of application servers. Most of it, very importantly, from a network perspective, was latency tolerant because a lot of things used to happen in an offline mode or in a not in a real time mode, right? If you're actually going ahead and doing a salary processing in a large enterprise, or if you're going ahead and doing some CRM application, a lot of things could be done in non-real time mode, because of which the network latency did not matter as much. And there was a lot of north-south traffic, what is termed as north-south traffic, where the traffic goes from multiple endpoints onto the centralized server, right? So the bandwidth was all in megabits per second and later on to gigabits per second, and mostly the LAN network. That has been the past era or era one of the enterprise network. Now, I'm talking mostly about enterprise networks, which effectively mean large scale networks that are used in enterprises and organizations, be it infrastructure like airports or ports or any such large infrastructure. I'll talk about it from a consumer or a telecom perspective also a little later. Then now what do we have? We have these massive GPU data centers. And these massive GPU data centers, you might have heard about all the news that is going on with respect to how massive these data centers are, how much of money is being spent on these massive data centers, how power hungry all these data centers are, which means that you have a large data center pretty much consuming the entire power which a mid-size or a large-size city would consume from a power perspective. And then obviously, once there's so much of consumption of power, one of the things that happens is the fact that there would be a lot of heat generated. And this heat is basically the percentage waste that would be there while computing. And that waste is actually converted to heat. And this heat has to be dissipated. So you have massive cooling mechanisms, be it water-based cooling or other mechanisms that are there, which are required to go ahead and cool the compute infrastructure, which is generating all this heat. Now, while all of this is happening from a network perspective, what's happening is there is serious amount of traffic that is there between the racks, GPU racks that are there, or GPU clusters that are there in the data center. And there is, because of which there is significant amount of east-west traffic that happens. Significant amount of east-west bandwidth, which means what? Which means the network inside the data center is operating at extremely high bandwidths and very little losses and very little latency, because there's a lot of east-west traffic. So today, if you look at the number of subscribers who are there on, say, ChatGPT, now everybody is hitting the same set of data centers, same cluster of data centers. A lot of work happens on these data centers. And if your request goes into one of the data center servers that are there, and you are asking for some image generation, it then gets pushed to a GPU cluster that might actually be focused on image generation. If you ask for audio generation, it might get pushed onto a cluster of GPUs or compute infrastructure that might go ahead and do the audio generation for you. So there's a significant amount of east-west traffic. Now, what is also very important to understand here from a macro perspective or economic perspective is the biggest cost element here are the GPUs themselves, which means you have to make the maximum or the most optimal use of GPUs. Now, because you have to go ahead and make the maximum use of GPUs, one of the things that you have to take care while engineering this is to ensure that the GPU is not idling while computation is happening, right? Which means the network has to cater to the GPU requirement rather than the other way around. Yeah. So now what is also happening because of it is the network bandwidths are in 100 Gbps to 800 Gbps. It's more than 800 Gbps as of now, right? So that is mostly what the data center build out is. And while that is happening, there are some baby steps taken towards a lot of the some of the AI work being done on the edge, right? So if you look at what Apple has announced in the last couple of days, they're wanting to do a lot of AI on your mobile device itself, right? Now that's a classic case of how edge inference might work in the future. Now, if the mobile device is capable enough, it will get done on the mobile device. But at the same time, it doesn't necessarily mean that everything can get done on the mobile device. What will happen is a classic distributed architecture where what can be done on the edge will be done on the edge, but what is required to be done centrally will get done at the data center, which means we now probably over the next 4 years, we would see a AI architecture moving towards distributed computing model where the large data centers that are there will go ahead and do a significant amount of centralized work that needs to be done. And the individual devices that might be there at the edge would go ahead and do a whole lot of AI inferencing. Now, because of the fact that the end devices will always need to talk to the centralized compute that is there, now the success of this application infrastructure where edge computing gets done is measured in milliseconds and not in terms of throughput, right? So you might necessarily need a sub-millisecond latency on the network infrastructure. Now, which is where, whether it's an enterprise infrastructure where you have to have a very low latency network, or if it's a telecom infrastructure or a cellular infrastructure, you might have to have extremely low latency communication over your mobile network, which means that you need to ensure that if you're still stuck in a traffic jam and you want to go ahead and consume AI, you still need to have the guaranteed service that the network should provide. So just to get into a little more details, from a point of view of how networks have been built out in the era one of server-led infrastructure. The network's job was more to connect many users to a few application servers. So these were all mostly application driven networking topology and networking design, right? So predominantly the traffic was north-south, the way you see it here, right? So you have mobile devices or enterprise desktops, laptops, or any other computing infrastructure talking to the enterprise switch that might be there. There will be layers of switches. It might be access switches followed by aggregation switches and then the core switch. But at the end of the day, they would all be connected to a bunch of application servers, and these application servers were catering to the requirements of the end user. So this was definitely not microsecond latency. Latency was high, but it was still okay because it was the applications that we're doing. So if you're watching YouTube also today, latency to a large extent doesn't matter whether it's YouTube or Netflix or any of the live video or any of the streaming video that you watch. Latency does not necessarily matter because there is an underlying technology that takes care of latency. So if you're watching YouTube on a very slow telecom network, it'll anyway buffer a few minutes of video or a few seconds of video upfront based on the connectivity quality that is there. So you can't necessarily make out any difference whether the latency is high or low. But applications also were like that, where it was all latency tolerant applications, whether it's email or file shares or web apps. right? The human speed is not necessarily in microseconds or milliseconds, right? Our ability to understand, consume content is not in terms of milliseconds. So you could have a web page might render itself in not necessarily milliseconds or whatever, and still it will look like good experience for you. So tens of milliseconds was perfectly acceptable. The compute lived centrally. A whole campus used to be centrally served by these servers. And there was a pretty good WAN network, the wide area network that was there, which was all connected over optical networks. And optical networks provide pretty good speed and a good degree of latency also for enterprises or large distributed networks. Now, let's get to what's happening currently, right? Now, there is the AI build out that is happening. There are these massive GPU data centers that are being built out. And why are these GPU data centers being built out? Why are those expensive GPUs that are there? Why are we having so much of power consumption? Why are having so much of cooling related issues, which effectively means water cooling, for example, and all these data centers are generally built out around where water is available in abundance. Right? All this is happening because AI, as you all of you would very well know, involves AI training, which effectively is creating the model. Right? Training a large model means thousands of GPUs working as one machine, and now, all this training is extremely compute intensive, because of which you need very high-end GPUs. Now, all of these computes as in GPU computes that are going ahead and doing the training will need to go ahead and talk to one another. So there are clusters of these GPUs that are built out. While that is getting done, in addition to training, AI is being consumed by centralized compute infrastructure as of today. So if you're using ChatGPT, while the GPUs are used for training, a significant amount of the ChatGPT consumption that you are doing today is also happening through the same data centers, right? This cannot scale, nor is it economically viable. Now, let's look at the key aspects. There's a significant amount of east-west explosion. GPUs exchange gradients every step. There's a significant amount of intercluster traffic, like the way I indicated about how vision processing might happen on a certain GPU cluster, audio processing might happen on a GPU cluster, and things like that, on a different cluster. So there's significant amount of east-west traffic. The other important thing is, while all these clusters are there has to be very little packet loss when there is transportation happening between these clusters. And a lot of technologies have evolved to ensure that there is zero packet loss and congestion control built in, so that the inter-cluster communication is lossless. That is something which has evolved. So a lot of focus has happened on what needs to be done for networks within the data center. And that is already there, that is already getting built out, that's already proven over the last 4 or 5 years, while these massive GPU data centers are getting built out. Now, in addition to that, there are the bandwidth required for inter-cluster communication is significantly high, 400 to 800 gig links. Then all of these are optimized to ensure that the compute and the data is as close as possible, because at the end of the day, the compute generally works on data, right? And the data also has to be as close as possible. While we are doing all this, the storage technologies have improved significantly to ensure that the storage latency is also reduced. Now, training is a batch job, which means that it happens over a period of time. The time to train matters. It might take a certain amount of days or weeks to train a large model. But a few extra microseconds per packet do not matter as much. What matters is the ability for the training to get done. The compute has to be as occupied as possible. But a few extra microseconds on a per packet basis necessarily do not matter, just because a significant amount of training is a batch job. Now, even while you're consuming the likes of ChatGPT or Gemini or Claude, it doesn't necessarily matter if it generates the image for you a few seconds late, or it generates the text that you want a few seconds late, or it generates a presentation for you a few seconds late, right? So latency is not as much an issue in the GPU data centers as much as what throughput is, especially from a training perspective. And from a consumption perspective, from the applications perspective, currently what you're using from a chat GPT or a Claude or a Gemini, it doesn't necessarily matter if the video gets generated a few seconds late, a few milliseconds late, or the text gets generated. You're used to it because it's not that like the moment you go ahead and give a prompt on chat GPT or Gemini, it responds instantaneously. There is a wait that is there and you're used to it. So just to look at the difference between training and inference. Now, from a training perspective, there's a huge compute that is happening in very few large GPU data centers. So this is where it is happening, right? Now, pattern of traffic is to a large extent east-west, and every cluster talking to every other cluster. What is it optimized for? The network is optimized for throughput and utilization. Utilization of the network, which effectively results in higher utilization of the GPU infrastructure, right? From a tolerance point of view, it's obviously very latency tolerant. We discussed about it. And the network metric is to a large extent TBPS at this point of time, terabits per second. And that's the network metric which decides whether your network is built out, network is designed properly. But let's look at it from an inference perspective. All this was for training. Let's look at it for inference. Now, where is the inference going to happen? The inference will happen on billions of edge endpoints, right? So what Apple announced yesterday or Google has been trying to do with their Gamma 4, which can run on a mobile device, is to ensure a significant amount of inference can happen on your endpoint, edge endpoint. Now, your edge can be your mobile device itself or your compute infrastructure that you have on your desk, or can be one layer of aggregation that happens for all of this. Now, what do I mean by this? It means that if you are a large enterprise or a large institution like yours, and you have a lot of desktops, there might be a GPU based server, which is not the one that has to be there in the data center, but a low-end GPU based server where a lot of inference might happen, catering to all the personal computers, laptops that might be consuming AI. Or in the case of telecom infrastructure, it might be very close to the first aggregation point of the telecom infrastructure, cellular infrastructure. So it might be very close to the base station as possible. Now, what's a pattern of traffic? There's a short request that will be there and a response that needs to come in. What should it be optimized for? It should be optimized for latency and responsiveness. There are, from a tolerance point of view, latency is critical because you can't go ahead and do certain applications where you ask for something and then the response comes much later. Now, what are those kind of applications? We will talk about it in the next subsequent slides. Now, what is a network metric that will decide whether the network has been designed properly, whether the network design devices are catering to what the user requirements are, right? It's a round trip time. The round trip time, which effectively means the latency. So that will have to be in milliseconds. Now, why should we have very low latency? What are the new applications that would be there, which would mean that inference happens on the edge? Inference happens at the user location. When I say user location, I'm referring to your mobile device, or if it's enterprise, the desktops, laptops, or other computer infrastructure that is not in the data center, right? Inference moves to billions of devices at the edge. And there are plenty of applications where your data center cannot scale or your network cannot scale if all of this has to be done in the centralized data center. These kind of applications, if they have to be done in the centralized data center. Now there will be a lot of AI that will run on your cars, your cameras, your phones, your factories, your sensors. And where are you generating all the data? You're generating all these data on these devices. You're generating data in your car where all the sensors are there. Your car has a bunch of sensors, your car has a bunch of cameras, your car might have a LiDAR or something else, right? And there's a lot of data that is actually getting generated in the end device or the edge device or your endpoint. And when so much of data is getting generated at the edge device or your endpoint, and you need to go ahead and pass it through an AI compute, it would take a humongous amount of network quality and bandwidth and a humongous amount of data center capacity to have these billions of devices going ahead and catering to AI if it's done in the centralized data center, centralized GPU data center model. It is not possible, it is impractical, it is not economically viable, and there are technology constraints also. Even today, if you go ahead and get stuck in a traffic jam in Bangalore, what you think is your 5G network practically operates like a 2G network, right? So in which case you can't be expecting your phone to be talking to a data center and getting you some AI application. So there are tens of billions of inference endpoints that are projected for this decade. Your autonomous vehicles, now it might be autonomous in multiple ways. It doesn't necessarily have to be a fully autonomous self-driving vehicle, right? While that is great if it happens and when it happens here in India or anywhere across the world, this even vehicles of today have a significant amount of intelligence in them from an autonomous perspective. It can be as simple as your newer vehicles have their high beam and low beam automatically managed by the car itself based on oncoming vehicles and things like that, right? Your collision alerts that come on your vehicle, a whole lot of stuff that happens today, or your cameras, for example. A lot of cameras do a lot of intelligent analysis on your device. So it might be as simple as a camera that goes ahead and shows you an image with all the light correction being done, right? Where everybody thinks they've taken selfies and they look extremely good. Nothing wrong about it, but the fact of the matter is it's the significant amount of image processing that is happening on the camera before it even shows you as your picture that you have just taken, right? Or other devices like the 360-degree cameras that are there, which actually goes ahead and takes multiple video images, stitches all of them together, and provides you on what you think of it as a 360-degree video, which you can process later on, which you can do a post processing to figure out what angle you want out of that camera feed that you have taken, rather than a fixed camera feed that is there today in most video cameras, non 360 video cameras and static cameras, right? A significant amount of industrial robots are already happening. A lot of factories are there which have more robots than people. There's a whole lot of closed loop automation that is happening. And these are all driven by a significant amount of AI that gets used. Your consumer devices are there, the significant amount of IoT and sensors that are there. And then there are these mobile edge compute devices nodes or the edge compute nodes that are there, which predominantly might be used in the telecom network, where the mobile edge compute happens. The mobile subscribers might have a whole lot of smarts, not only on their device, but what the service provider compute might be there at the edge. And all of that happens. So these are the kind of new applications that will significantly use AI going into the future. All of them will be tens of billions. In addition to that, all of them cannot necessarily have the kind of network that is required for everything to be done on a centralized GPU data center or AI data center. You might want to have a lot of inference being done at the edge so that your AI experience is one as required for that particular application, and more importantly, economically viable, because you're having $1,000 phone on in everybody's pocket, and it's got a significant compute infrastructure. So whoever is providing the AI service is actually making use of your compute infrastructure rather than trying to go ahead and put up everything in their GPU data center, which will become economically unviable if that has to be done, assuming the communications infrastructure still provides that. Okay, so this is what the future is from an AI perspective. And when this has to be real-time AI consumption, it effectively means it's real-time inference, and that inference will happen on the edge, and the networks will have to be built out to ensure that edge inference happens in a in an extremely good set of parameters that are suitable for edge inference. And hence the networks will have to be evolving and will have to evolve to provide the network design, the network parameters for edge inference. So now at the edge, latency is the product, because if latency doesn't work well, your product practically fails, right? So edge inference sits inside the real world loops. A car braking automatically, either because of the fact that it's an autonomous vehicle or a different level of autonomy is still provided. Your collision detection alert is still provided even today by the basic cars that are coming out in the market. All of this has to happen as soon as possible. You can't be expecting to send out the images that the cameras of the car is seeing, send it to a data center at the back end, and wait for the response before a collision happens. A collision would have happened by then, right? Significant amount of physical AI is about to take off, right? So broadly, AI can be considered as physical AI and software AI. Software AI is all your chat GPTs and all the images and the text and poems and everything that gets generated. Physical AI is where a physical aspect of automation is involved, which effectively might be a bot which is going ahead and working in a factory, sorting out different physical components that are there, or it might be a dog that is going around from a surveillance perspective, right? All of that will take off big time. So the physical AI part of it is huge going forward, and entire physical AI infrastructure will require edge computing or edge inference. So slow inference means a product is not working. Autonomous driving, we will need less than 10 milliseconds of inference. It has to sense, decide what needs to be done, and actuate what has to happen because of the sensing that is done or because of the inference that is done in less than 10 milliseconds. Industrial controls will have to do everything that they have to do in less than 5 milliseconds. Live video AI will have to be in less than 30 milliseconds, because there's a lot of analytics that would get done on the live video. This is not the standard video applications that we're talking about, but video applications going forward. So if there's a live translation of what I'm talking now into, say, 4 different languages, all that has to happen live, right? So all that requires edge inference of less than 30 milliseconds. There'll be billions of interactive agents, which are basically AI bots, which needs to operate at about 100 less than 100 milliseconds of latency. So the this is below the human perception of instant response. Like what I mentioned some time back, watching YouTube, it buffers for the first 5 seconds to 8 seconds to 10 seconds. And then even if you're watching a 4K video on YouTube, everything seems fine, YouTube or Netflix or whatever, right? Or if you go ahead and give something to ChatGPT and it responds back to you, you feel it's instant because it's below the human perception of instant response. So as long as it's below the human perception of instant response, it's good. But that is when it's a human interacting with AI. But if it's a system interacting with AI, like autonomous driving or industrial controls, then the latency has to be extremely low. The challenge is the fact that a significant amount of latency is because of the network, right? End-to-end latency has to be looked at as the latency of the compute and the latency of the network. Now, what's happening with respect to latency of the compute? There is significant amount of accelerators that are being built out, which is shrinking the inference time from a compute perspective, right? So the fact that your NVIDIA GPU today started off more as a accelerator for graphics processing is the fact that compute will continue to evolve to reduce the inference time. And when that continues to evolve to reduce the inference time, communications or networking might not keep up with the shrinking inference time from a compute perspective, which means a round trip across the network increasingly dominates the latency budget. So the distance is become the latency now. So if you really look at it, we might continue to go ahead and improve the latency of compute, but irrespective of how much it improves, it would the bottleneck might actually be the network. So when I say network, this includes the networking devices and what happens inside the networking devices and the communications infrastructure between the networking device and the cloud, or the GPU cloud in this case, which effectively means the communication from your laptop, desktop, or servers to the cloud infrastructure, or the communication infrastructure that is there between your cell tower or cell phone to a cell tower to the backhaul network. Right? So the network has to be designed, the network has to cater to the low latency that is required for the future of AI, where billions of devices will do edge inference. So what would an edge inference network look like, or what should an edge inference network be designed for? It should be designed for ultra low bounded latency. Ultra low latency, very simple to understand. It should be a single digit millisecond round trips, right? And bounded latency is we have to have the ability to know this is what the latency would be. It should be deterministic to a large extent. Guarantee should be there for the network latency and not varying based on different parameters from a AI perspective. The compute will be pushed to the edge, the mobile edge compute and on-prem nodes, so that inference happens one hop away, not a continent away. So the chat GPT that you use today is an inference that happens a continent away, right? Today also inference is happening with every AI consumption that you're doing. The models are getting built when Claude or chat GPT goes ahead and releases an opus model, right? The models are trained, the models are built. When you use it, it is only the inference that is happening, right? So today the inference is happening one hop away, which is a continent away, which might not necessarily be the model that will scale, which is where the inference might have to happen, if not on the node itself, edge node itself, at least one hop away, right? So it has to be deterministic and lossless, because any loss in packets will mean that it has to recompute, which means the GPU will have to go ahead and redo the work, which means that many tokens are consumed, which means the cost of that particular AI application is that much higher, right? So jitter and packet losses are very damaging for raw latency, which means you need to have deterministic and lossless networks as far as edge inference is concerned. We have discussed the need for distributed and hierarchical networks. You have to have a tiered device model where you have an edge, you have regional core, then each model will have to be placed where the latency budget allows. So you might have certain inference happening on the device. Might be some inference happening inside the campus or in the service provider's base station proximity, so that the inference is not one continent away. And these are the networks that might have to evolve, where the network architecture might evolve differently than what it is today. The communication technologies like 5G, 6G, or 100 gig Ethernet, 800 gig Ethernet might also change. And in addition to that, the architecture will have to also change. Typical of most of these large networks, you also need to have security taken care. when you have millions of endpoints, you actually are increasing the attack surface, which means at every layer, you need to ensure identity and segmentation of every loop or every hop so that the entire network cannot be brought down by one rogue actor. Now, any large infrastructure of this kind, be it at a network level or a compute level, when I say compute, I'm more referring to the AI compute, you need to know what's happening. And unless you know what's happening, you will not be able to manage it, right? And the scale of how things are happening today, you can't manually manage any of this, which means to understand what's happening, you need to have an observability layer which observes what's happening at the network, compute, and every layer. But let me limit myself to just the network layer here. Your entire network layer needs to have an observability platform or observability mechanism built in so that real-time telemetry is available from the network infrastructure. Now, this real-time telemetry is also so voluminous that it cannot once again be managed manually, which means you need to have AI engines, AI solutions that are actually reading the telemetry data from a observability perspective, deciding whether the infrastructure is operating in an optimal manner or if there is a breakdown, and go ahead and take necessary actions to correct it if required. So there's a closed loop control system that needs to be there. And you might have different kinds of services, you might have different quality of service that needs to be provided, in which case you can't go ahead and once again do this manually. It has to be autonomous. It has to be autonomous to the extent where you have a particular service that needs a much lower latency, the system should be able to automatically take care of it and not wait for a human to go ahead and provision the networks for that. So these are very critical things going forward from a network perspective with what the future would be. So, in a way, to summarize, the network is the new bottleneck for AI. Compute moved from servers to GPU data centers, and now it will move to the edge. Each shift changed what the network is optimized for. So when you had a mainframe computer with just dumb terminals connected to it, people were all close to it. The network was not necessarily a huge issue, and these were all connected over extremely low bandwidth networks. Did not matter much because a significant amount of computing was all offline computing. The amount of work that the mainframe had to do was a lot more than what a dumb terminal would have to do. And when things changed to client server, obviously there was a centralized compute, but there were a lot of work that is getting done on the edge also, or at that point of time, the personal computers and things like that. But that was facilitated and that was possible just because of the fact that the network as a concept, the network technologies evolved where you could go ahead and have high speed optical networks connecting every piece of everywhere in the world. So anywhere in the world was connected, interconnected over optical fiber networks, the submarine cables and all of that stuff, right? So the networks grew. That is where the internet also grew. So the networks grew, which enabled the ability to go ahead and do client server computing. And then it was the networks that grew because of which you could go ahead and use Amazon AWS, which is once again in a way a centralized compute infrastructure without worrying about anything because the network was making it possible. Now, when things are evolving into AI inference to be done at the edge or to be done in your devices, the network also has to evolve for it. So most of the bandwidth that has been built is built for training. Now, inference needs low latency. The next decade of networking is one in milliseconds latency and not what it is today. So, edge inference networks must have extremely low latency, highly deterministic, will obviously be distributed across billions of devices, and needs to be secure, without which the infrastructure can be brought down. And the compute needs to be placed as close to the device as the latency budget demands. What does this mean? This means that the compute needs to be as close to the data which is getting generated so that you can go ahead and consume that data, infer from that data using the AI model as close to the device as possible. That is what is edge inference. I think I've finished this probably 10 minutes before 1 hour. So we can get on to questions or any discussions if you want to. I felt that if I go on for longer than 1 hour, uh, you might not be able to go ahead and maintain the same level of interest. So I think we can move on to any questions or discussions that you might have.
Thank you so much, Raghuvar sir, for that wonderful session.
Thank
Before
you.
we conclude, we would like to open the floor for a brief question and answer session. Dear participants, this is your opportunity to ask questions, seek clarifications, or share your thoughts with our resource person. Please use the chat box, raise hand option on screen, and we will unmute you.
Okay, I see a question here. Is distance the only criteria for low latency? Uh, it is one of the very important factors for low latency. While it's not the only factor, it's definitely a very important factor because at the end of the day, the distance that the digital bits will have to travel will indicate how long it will take. But very important criteria, but not the only criteria. I'll tell you the reason why it's not the only criteria. I'll get into a little bit of technical details. Now, if I'm doing something on my mobile device which is connected to the cell phone towers, and then the cell phone tower, then there's a backhaul and all of that stuff, right? Now, there is some amount of computing that is happening on your mobile devices itself. When I say computing, I'm more referring to computing that is required to enable the communications infrastructure. So my Bluetooth chip is working, my Wi-Fi chip is working, my GSM chip is working. Similarly, on the network devices, whether it's the routers or the switches, there is a latency that the routers and the switches themselves will introduce. There's a latency that the base station will introduce. There's a latency that the core, the 5G core or the 6G core or the 4G packet core will introduce. Those latencies are anyway there, and that also needs to be taken care. But the distance is one of the telling factors, considering the fact that the rest of the latencies are to a large extent known, not variable. Those latencies that the network device might introduce is a fixed latency, whereas distance brings you the variable latency. So that is the reason why distance is an important factor. I hope I answered your question.
We have time for one more question. Is there any participants?
Sir, can you suggest any small projects so that the students will be able to take up in their final year? Usually 6 months to 1 year time, considering the academics.
Sure. I think there are three areas of AI in general which students can focus on. I sort of categorize AI into three buckets. One is algorithmic AI, which is all the algorithms that needs to be written, the gradient descent or whatever, all that. The transformer architecture itself is algorithmic, right, in a way. But all the algorithmic AI, that is one bucket. The second bucket is basically Gen AI. And when I say Gen AI, you're talking about LLMs here. And you can do a whole lot of activity or projects from an LLM perspective. Classic would be, what do you do for data that is not already there in the LLM, right? You go ahead and do a RAG, or you do fine tuning of the LLM. And fine tuning of the LLM is a good project to take up. And the reason why I'm generically calling it as fine tuning of the LLM is because your fine tuning will have to be done for different domains. So there is a domain specific fine tuning that is required. So you might want to go ahead and, for example, if I have to give you a finance related fine tuning that is required, right? You should be able to go ahead and take the entire income tax rules of the country, your entire GST rules of the country, your entire TDS and related rules of the country, and go ahead and provide all this data into an LLM, fine tune it, obviously an open source LLM, fine tune it so that that particular large language model, or when fine tuned, a small language model will be able to cater to one, run on low end compute hardware. It would not necessarily require x86 NVIDIA GPU, should be able to run on x86 boxes. There are a lot of open source uh, language models that are coming up. Gamma 4 of Gemini, Google is one such example. But if you go ahead and fine tune or distill with domain specific knowledge, your inference will be that much accurate. The LLMs or the language models would not hallucinate that much more. Your ability to go ahead and get accurate answers will be that much better. So that's a generic project I would go ahead and suggest, building domain specific LLMs by fine tuning and distillation. Then the third bucket of AI that I look at is basically building agents, which is automation of software with the multimodal architecture of vision, data, audio, everything. The significant amount of agents can be built, which will automate a lot of things. And these are things that are extremely important. While doing this, from a communications or a networking perspective, you can go ahead and build out a significant amount of agents for making the management of networks that much simple, understanding the issues of latency or for the future.
Sorry for the interruption. Somebody else was talking. Go ahead, sir.
Yeah. So that is what it is. Three buckets of AI, the way I look at it: algorithmic AI, language models, and which is generative AI, and agentic AI, which is basically applications on top of the language models. So these are three buckets. Fine tuning and distillation of LLMs for domain specific knowledge would be very useful. That will be a generic project area that can be taken up for different domains. And developing agents for automating of software across multiple domains, across multiple requirements, is something which is very useful. And if you just look at everything that we are doing today, either in the institutions or ourselves when we do it at home, and just see what can be automated. Fundamentally, AI is all about automation, be it software automation or hardware automation. We do all today, I would say significantly 60% of the work that we do today is basically routine, repeatable work, which AI can do extremely well. There is one question which says, what are the challenges of
now, sir,
Yeah.
that opens two questions for me.
Sure.
One is, you mentioned that it is domain specific. So when you specify the domain specific, my question is, now the college, we have about 8 engineering departments, and usually this computer science or computer science with AI students will be more or less will be doing such type of 3 areas which you mentioned. Would you recommend that some other branch of engineering like mechanical, civil, electrical, electronics, or artificial robotics, so these people can jointly work on this? That's my first question, sir.
Sure. It's a very interesting question because I have a point of view of what the future software engineer would be, right? Because a lot of talk about the fact that software engineers are not required in the future because AI is generating the code and all of that stuff, right? Which is actually the reality also to a large extent. Now, over the last 2 years itself, something like a Claude has evolved so well that a significant amount of software can be generated by AI. Now, is it a huge threat to software engineers? Is it a problem? Is it something that is very new that is happening? I don't think so, because the way I look at it, right, we were writing software programs using programming languages like Python or C or whatever, which was nothing more than a syntax-driven language, right? Now, and that syntax-driven language, whether it's in Python or Go or C, was then fed to a compiler, which would actually generate the code which was understood by the machines, computers, right? So instead of writing it in a syntax-driven model, in the syntax powered language or a syntax constrained language, we just now have to write it in English. That's the only difference. So you can almost consider the code generation that is happening because of AI as what our compilers were doing. And we never questioned the fact that compilers were going ahead and creating a machine code. And now we think that there's a problem. So, what is the advantage of this? The advantage of this is software engineers having the skill of just the programming language is not sufficient because you can write it in English, which also means what is more important? It's the application of what you do, which is more important. So, software engineers have to become more of product designers, application designers who go ahead and look at a problem and convert that problem into an application or a product. And that is where the future of software engineers is. So anybody who can articulate very well, anybody who has a good understanding of how to convert a problem into a product management strategy, those are the software engineers who would do extremely well. Now when it comes to other domains, right, the fact of the matter is the application building these days, in the last 15-20 years, has been highly inefficient now on hindsight, right? So just take a ERP application, for example. ERP requires certain supply chain expertise. ERP requires certain finance expertise. ERP requires other domain expertise that might be required. And it's a software engineer who goes ahead and codes that ERP application with a ton of issues. So it's the domains expert who's a CRM expert, who's a manufacturing expert or a finance expert who has to learn software rather than the other way around. So increasingly going forward, what would be required is domain specific stuff. So I think a pairing of computer science engineers with domain engineers to create domain specific applications is what would be the future. And this is the best way to get the efficiency going forward. So if it's mechanical engineers or electronics engineers or electrical engineers, the significant amount of value that they bring in from their domain expertise, pair them with computer science engineers, and that is where the future is.
Yeah, thank you, sir. That's a very insightful thought, which some of the students may be thinking that there is a barrier of department, which I'm sure that barrier of department doesn't exist. Everything what you do is interdisciplinary. So coming to the second question, sir, now as you are very much aware that your academic as well as industry expectation is there is a big gap. So we cannot solve everything. So from my humble request for Jyoti Engineering College, whether will you be able to mentor a few batches as an external mentor, online only? There will be an internal, but again, internal faculty members will have restrictions like we are not used to the real environment. And whereas you have real expertise on this all hardware, even on the today I was listening that edge and all become again hardware systems, and again it should be closed, and there are lots of challenges into this also. So a small problem, if you person like you to mentor, maybe 1, 2, or depends on your time, it will be appreciated. So can you please help us, sir?
Certainly, I will try. Give me some time. Let me think through this and I'll get back to you. I would definitely want to help as much as possible. I will probably do it. Is just that how much of bandwidth I can spend is something which has to be worked out, and I'll get back to you on that.
Yeah. I'll take the other questions after giving opportunity for others. By the way, I worked in ERP systems like Maximo and partially on SAP also, which I'll explain. We will discuss later on, sir.
Oh, okay, sure.
Yeah. Over to Prajun or you take the other question, then we'll come back.
Sure. I think I see a question here which was there. Just give me a second. What are the challenges of deploying AI inference in data centers or industrial environments? Right. So in industrial environments,
maybe the sharing you can switch off so that people will see your face completely.
Sure.
Yeah, go ahead, sir.
Yeah. So what are the challenges of deploying AI inference in data centers or industrial environments? So going forward with the need to do edge inference, the data is getting generated in the industrial environments or on our devices or in our car or whatever, right? So the compute has to be as close to the source of data generation, which is why we are calling it as edge inference. Now, should it be there in a data center? Yes, inference can be done in a data center, but not the current model of data centers. The current model of data center is, to a large extent, if you take a chat gpt or aws or something like that, there are some 8 or 10 data centers across the world, and everything gets consumed by that data center to go ahead and provide you the AI inference that is required. It might actually go ahead and become distributed data centers, where they might be, if you have a service provider like a Airtel or a Geo, they might have a collaboration with, say, ChatGPT or OpenAI or Anthropic or one of whoever, or Google. And there's a significant amount of inference that might happen in the data centers of your service provider. Similarly, in enterprises, there might be data centers, but not necessarily the massive multi-billion dollar data centers that are there in enterprises. You might still have low-end compute and low-end GPU infrastructure to do inference as close to the data as possible. Industrial environments, very large industrial environments, edge inference does not necessarily need to be the device itself. It can be one hop away from the edge, which is some kind of aggregation that might happen. If there's a large industry, has a bunch of machines and automation environment that is there, all of them might be connected to a local data center, which is residing inside the industrial environment or the industrial infrastructure of that location. And that might do some level of inference. And the way the LLMs are playing out, the way the application of architecture is playing out, is the first layer will decide what can be done locally and what has to be sent to the data center. So it might not necessarily be that everything happens in my local edge inference only. The applications are being designed and built in such a way that it can take a call on, this is basically known as a routers in the AI context, which decides which LLM to call, which data center to talk to. All of that will happen. Very similar to how what's happening today in, say, when you're shopping on Amazon, you don't even know where the compute is happening, right? So when you're shopping on Amazon, it automatically shows you the recommendations. That recommendation might actually be coming in from your nearest AWS data center in Mumbai or Chennai, whereas you can be actually looking for some product which is not available in the local this thing. So if you're searching for it, it might send it over to a Japan or a US data center, and you would not even know. All of that would be hidden. So there will be edge inference, there will be the data center inference that is there. Applications will become smart to really figure out which inference compute infrastructure has to be chosen when.
We have one more question in our chat box.
Yeah. So with AI becoming a bigger part of communication networks and edge computing, what skills should communication engineering students focus on learning today? And what research areas do you think have the most potential for young researchers in the future? So firstly, you have to understand the concepts of AI and the AI architecture and how things are happening overall. And then you have to focus on the communications part of it. The need to ensure that there is low latency communication from the edge point of view to the low latency at the communication link and low latency in the systems itself, the communication devices itself, right? That is also important. Now, from a communications perspective, one of the things that you can look for from a research perspective is to go ahead and see how managing networks and managing communication infrastructure becomes that much easier and autonomous, which means a significant amount of AI is required. When you have billions of devices, like what I mentioned sometime back in one of the slides, your management of the networks will have to be autonomous. Your observability will need to be automated, where the AI is observing the behavior of the network based on the changing behavior of the network, it'll flag it off as an issue that might be there, or might have to go ahead and change the parameters for better quality of service. So those are areas which I think will be significant.
Thank you for those excellent questions and for your
Now,
generous response.
I'll take one more question. I think Kiran sir is online, sir. Kiran sir, are you still there? Oh.
Yeah, I'm very much there.
Sir, you can also give a surprise note. You have been with the same industry for more than 30 years working in Infosys, and you have exceptionally outstanding experience in various domains, and particular to AI and AI tools. Maybe another 5 minutes, 6 minutes, you can talk something message. So this may be another opportunity where our faculties from various parts of India are attending. So over to you, sir. Raghuveer sir will come back to you, sir.
Sure.
Yeah, coincidentally, me and Raghu go back to 40 years. We have worked together, both in the earlier company as well as in current company. And now also we continue to collaborate together for giving back to society. So, and what I have been doing faculty development. In fact, 2 days back, I was in one of the leading universities here in Bangalore, RV University. They had invited faculty from almost all the leading universities and engineering colleges, both in Bangalore and Mysore. In my experience, so this AI and agentic AI and all these new developments, these are all the tools, and it doesn't again drastically or dramatically change the way we are teaching or the way the students are learning and the way we are preparing the students for the larger contributions which they can do post the education. So this again we have to bear in mind that we cannot outsource thinking. And this was reiterated, and it was my hypothesis was reconfirmed when I was discussing with 120 plus faculty 2 days ago here. So what we need to do is, even when I engage with the students, before a month ago, I was again in RV University discussing in person with about 60 of their third year and fourth year students. When I say, which problem you want to solve in this world or in India, or what do you want to do after this college, everybody is talking only about agentic AI or AGI and all those things, the fancy names which are there, and everybody is in a race to find out who knows how many number of tools. And also they take pride in telling, I have created this website, that website, and most of them are still continue to do vibe coding. So this is a very dangerous trend. And why me and Raghu are able to adapt to these emerging technologies. If we look at 40 years ago when we graduated, we had not even, probably we just knew about C, that's it. That too on a plain DOS window, that is the character window. Now, how did we able to seamlessly get into this AI world or agentic AI world or RAG and all these things, how we are able to do seamlessly is because of the foundation. So that's where the education institute like yours, premier institute like yours, you have to confirm or ensure that all your students don't skip learning the foundations. Once the foundation is built, then using these tools, they can only amplify their effort. They cannot bring in new ideas or new inspirations by themselves. The ideas and inspirations have to come from within, from the students. That's what we need to focus on. Otherwise, what will happen? They will get overwhelmed and they will get lost because of, as Raghuveer mentioned, so many new things and new areas which has emerged. So it will be overwhelming if the students don't have the focus. So they have to again they have to fix one or two domains. Again, they cannot be master of all the domains, and go deeper into one of these full stack technologies. In the absence of the understanding of these full stack technologies, then they will have many challenges. Otherwise, what will happen is these very soon all these agentic AI or any of these latest AI models will soon replace these people if they are just doing the vibe coding. So that is the message I would like to give, sir.
Yeah, just to add to what Kiran mentioned just now, the presentation that I made was completely 100% generated by AI without me editing one line of it, one word of it, right? But I have to still go ahead and tell AI what I want, what is the flow that I want, what are the topics that I want it to cover, which is when it will give you what you want. So it's more of a tool to go ahead and convert what you have in your mind to something in a very accelerated manner, and you need to know what to ask. And that is where I think students will have to focus on. And another extremely important thing is to go ahead and do as many projects as possible. Any amount of theory will not necessarily help in the long run. Very useful, important, but any theory that they learn should be backed by practical skills that they can go ahead and get, which is where a big difference will be, which is where the fine tuning of the mind is more important than fine tuning of the LLMs.
Thanks, Raghu. And I don't know how many of you are aware, I am mentoring 400 of your students, thanks to Dr. Sojan Lal, introduced me to his students. And in fact, just before this call, I was with them. So I was talking with them on an online meet, and they have come up with wonderful ideas after I nudged them. If you have infinite resource, infinite time, and infinite support, what is the one problem you want to solve? Sojan sir, you have to, I think you have to circulate that problem list with all your faculty. Then you will see how wonderful it feels that your students are already on the right path.
Yeah, good. That is really good, sir. And also, as just Raghuveer sir supplemented, your intellectual skills are used to make this presentation and the flow, which was your correctly also. And again, coming back to the summary of what Kiran sir and Raghuveer said, I request faculty members, which has actually come up from the last week, there was an FDP, and one of the resource persons said, for any engineering colleges, maybe like 10 years back or even before, yearly project used to be given. One project, 1 year. So now Kiran sir also joining with this. So we do say that there should be a monthly project, at least. Yeah, and then later on it will be daily or weekly. So, but at least let us come to a closer range, which is very easily accessible. SMAC monthly project. That is one thing. Second thing is question to Kiran sir, because you are more than 30 years with Infosys, and you have extremely, and also that now 13 million people are there, and everything is, you are the backbone for designing all this. Now, how the currently this Infosys Springboard can help in learning things, because the platform is completely free, and I understand about 131 certifications are there, more than 20,000 plus courses are also there. So maybe in 4 or 5 minutes, you can brief about, at least for the people, because not in all colleges that is been utilized properly, but there are certain colleges, they are extremely well in doing also. Over to you, Kiran.
Thank you. Yeah,
Can I just interrupt you for a second?
Sure.
There's one question, so I'll finish that answering that question, and then afterwards you can take over. So that way,
please.
this will come to a conclusion. So the question is prompt engineering more important in the future? Right. So I'm assuming they're asking, would prompt engineering be the important skill going forward? Now, it's been only 2+ years or so since all this has happened, and everything started with we giving a bunch of prompts and things like that, right? Which initially was simple. Go ahead and give a bunch of prompts. That is all good from a consumer perspective, but from a technology creator or a computer science engineer who has to go ahead and create projects which are fairly deep and fairly large in size, you can't necessarily keep on going ahead and giving prompts and expect the prompts to give you some output which you can collate and assemble everything together. So prompt engineering, which later in some form or the other was called vibe coding, has now moved on to as what is known as a spec-driven development. In spec-driven development, you don't necessarily give prompts the way it's understood. You go ahead and write the PRD, and which is a product requirements document or related documents, where you create a document which outlines what you need, and then be it Claude or anti-gravity or whatever, looks through these documents to understand what needs to be done and can go ahead and create complex software, not just a bunch of prompts which would go ahead and give you a code output which you can put together after that. So be it for code generation where you have spec-driven development, or you can expand it to other non-coding related tasks also. So spec-driven development is the best way to go ahead and do that, which effectively means you go ahead and create a PRD of outlining what you need. You go ahead and create your UI UX guidelines or your documents outlining how your UI UX has to be generated by AI. You can go ahead and indicate what should be the testing strategy based on which the testing strategy and the testing of the applications will be taken care. So in effect, prompt is good for simple users. Prompt is good for getting some instant output, not necessarily I'm talking about the traditional way we look at prompting, which is just opening a chat window and typing something. That is not necessarily the future for building deep applications, for building something which has to be repeatable, for building something which has to be evolved over a period of time. You have to get onto spec-driven development and other models that are emerging. And then because of the fact that human coding was to a large extent considered deterministic, in the sense what you code is what the computer or the CPU does, was considered to a large extent deterministic. I have my own doubts about it because humans also have made significant errors in software coding, but that apart. Whereas software generation using AI is probabilistic to a large extent. So you have other concepts of harness and all of that coming in. So effectively making it more deterministic as far as what the output would be, factoring the probabilistic nature of AI or large language models. So I've answered, I think, the last question. So Kiran, take over, please. Thanks.
Yeah. Meanwhile, if any other questions are there, put it in the chat box. We'll take it. So over to Kiran, sir.
Thank you, sir. So I have just pasted my blog, which I wrote yesterday after this faculty development workshop of 120 faculty yesterday, day before yesterday, which I did. Yesterday, I have published this blog. I encourage all of you to go through this. Here, I am a proponent of one very interesting statement which I am going to make. Knowing makes no difference. So today, last 90 minutes, we heard many things from Raghuveer, and it doesn't make any difference to any of us unless we practice it. So that's very important. And this practice, it's not, for example, if I have not done exercise in my life, if we tell you from tomorrow onwards, it's good for you, tomorrow onwards, you go and do exercise, we will take care of all the cost. We will give you all the mentors and motivators and fitness experts, etc. Whatever facilities the college or university might give, still the motivation has to come from within for you to get up early and go for a walk or a jog or a gym. So the same concept applies even in AI world. So far, you have not used these AI tools. Suddenly, everything looks so hunky-dory. All the LLMs, all the vibe coding, or all the RAG, and everything looks so interesting. And yeah, people like Raghuveer are also there to help you. Still, unless you pick up a project to do, so it's of no use, and you will go back to the same old things, because all of us are adults. All of us have formed up our ways of learning, our ways of working, and we also have a very, very strict list of what motivates us. If you stick to the same old things of doing it, it means if you keep doing same thing again and again, you will get the same results again and again. If you want different results, you need to do different things. So that's what my hypothesis was also reaffirmed yesterday. Because one of the biggest challenges is all of us are comfortable. For example, suddenly this LLM, and again, I will extend to what Raghuveer said about the prompt engineering. Yes, we can go and do vibe coding. For example, even if I want to generate the content for, let's say, ADA, analysis and design of algorithms, then without knowing what is that you want to generate at what level, there is no prompt which will help you to generate. Even though you do a PhD on prompt engineering, you cannot, if you don't know the subject, then obviously you have to go and refer to the book which has been written by one of the leading professors who has extensive experience in ADA, or designing the algorithm for various problem statements, or it could be even an e-commerce website like Amazon.com, what was the algorithm which has been followed? So unless you go refer to a book or a lecture by an experienced professor, so that is where now I'm joining back to Springboard. On Springboard, yes, 20,000 plus courses. They are not just off-the-shelf books which we have picked it up. We have curated based on the industry standard books which is prescribed for our own engineers who are doing projects for our clients. We have 20,000 such courses, and most of them have been sourced from universities across the globe. So these are the courses created by the practicing professors by leading universities, including Ivy League universities across the globe. So this is where you can only augment the learning which is required. If you don't understand the concepts, or if you need additional alternate examples to whatever is referred by the respective professors, that is when you can augment it using any of these LLMs, be it the Notebook LM or be it AI Studio by Google. So all of these are Anthropic. It will definitely help you to take your learning to the next level. And also today, most of the sessions happen. For example, Bangalore Tech Summit happens. There, they bring in all the practicing startup entrepreneurs to narrate their success stories. And these are all, even billionaires will come, unicorns will come. And when you listen to their story, unfortunately, what will happen, this entire day's proceedings will be given to you as a 8 hours of podcast or a YouTube live stream. Then you can use any of these LLMs to shortlist what did this Mercer CEO told about it? What did Nandan talked about it, about the race to the top or race to the bottom? These are how smartly you have to figure out to consume these LLMs and these prompts so that your learning will goes to the next level. Then another problem with there is too much of content availability in the market or in this space is fear of missing out. If you want to consume everything which looks cool, which looks, if you try to emulate some other university which is consuming, then without any focus, again, your students will be lost. So again, let me stop here. Only thing which will work in my experience is you have to ask what is the challenge or the roadblock which you have. Then one of us can tell you here is how you can move ahead. This is the only way which you can go deep into whatever purpose, for whichever purpose you are learning these techniques. Otherwise, there are too many things are there in the market and it is too overwhelming. And especially, it's a very big challenge for academia and universities to catch up with the industry, because the speed at which the technology is evolving, it's very difficult to catch up, be the students or the professors. So please don't try to catch up too many things in one go. Have a focus and go deep into it. Then definitely the industry leaders can help you to go in depth. And I also encourage all of your students who are pursuing a project or an internship, instead of doing an isolation, these projects in isolation in a hurry. And I also saw when I was polling, some of your students are doing 3 internship, 4 internship. It is not like a stamp collection. You need not have to do too many internships. Please do one internship with focus, with a purpose. Take it forward as a startup. For example, internship doesn't mean that it has to be theoretical and a report has to be submitted and move on. You have to take it as your own child or your own startup and take it further. How does it matter? You have to have just one milestone which you will finish in, let's say, 8 weeks and submit it so that you will earn credit and take that idea forward. Who stops you? You can be an entrepreneur with that idea, because you are pick up a problem which is closer to your heart and solve it for the society. And I'm sure we are there to guide you how your students can make money out of it, how they can make somebody to pay a price for the value they are adding. So that is when the purpose comes in, then all these things definitely will amplify the rate at which they are skilling themselves. Thank you, sir. That's all I wanted to share.
Yeah, thank you, sir. And it should be based on future plans. Not that they will do on multiple ones. And also, if possible, it's a domain specific, either 1 or 2 domains. Let them choose based on their future plans. Then you have to work on this. As we are coming to the close of the session, maybe another 3, 4, 5 minutes. Raghuveer, sir, you can tell any closing remarks, sir, before we'll pass on for the other sessions. Or also, some of you can unmute and give a feedback also. That is also welcome, so that we can improve what is good you found, what needs to be improved. maybe after Raghu sir session. How do you, sir?
Yeah, thanks a lot. Don't have too many comments to make, except that this is a time where we all need to learn whatever we learn very deep. No point in having surface knowledge, because significant amount of knowledge is already available in the form of LLMs and AI. So we need to have deep knowledge, need to have deep domain knowledge. Ability to combine deep domain knowledge with what we can do using AI is the future.
Good. Maybe one or two feedback if anybody wants. Otherwise, Prajun, take it off. Or Neetu, Chippy, anyone?
Okay, sir. I think no one is responding. We'll wind up the session with a vote of thanks.
Thank you, Raghuveer sir and Kiran sir. On behalf of the Department of Electronics and Communication Engineering, and behalf of all our participants, I extend our heartfelt gratitude for this truly enriching session. Thank you very much, sir.
Thank you. Thank you all.
So once again, thank you, sir, both of you, Raghuveer sir and Kiran sir, and all the participants, and appreciation to the department. Thank you, and we'll meet you again.
Thank you.
Closing on the right time, 2:30.
Have a nice evening.
Yes.
Thank you.
Thank you.
Thanks.
Sir, both of you, Raghuveer sir and Kiran.
Dear participants,
Please close the recording, please.